In this lesson, we will look at normal distribution curves. So, for example, this one right here is showing a normal distribution curve because it has the highest is the middle, that's like the average, and it goes down on both sides. So this one, this shape is a normal distribution. And the way it's shaped is shaped like a bell curve, which is symmetric. So we can see that curve here, so it's the same on both sides, symmetric. For our next blank, the area under the curve is going to show us our probability, because it's always going to be shown as a percent, with the total adding up to 100%. So there are two parts to it. So there's the mean and the standard deviation. So we know the mean is the average. The standard deviation is our new vocab word, which you can write over here. It describes how spread out the data is. In other words, how far from the mean. So on our diagram, we can see, so this is the symbol for mean, which is here. So we can see that the mean goes in the middle, and then as we get farther from the middle, it kind of goes down to show that there's less people in that area. So 1 standard deviation, 2 standard deviations, 3, and it also goes the other way. So as far as what it looks like, this curve is going to show how the data is spread out. So in this section, within 1 standard deviation, there's 34.1% of the data. And since it's symmetric, it'll be the same on both sides. And we'll look at this in an example in a moment here. So if you're talking about height, the average height for a male is 5'10". So this could be 5'10", and then a standard deviation could be 4 inches. So adding 4 inches or subtracting 4 inches, so 5'6". So 34% of the population is between 5'6" and 5'10", approximately. So up here, approximately blank percent of the data falls within 1 standard deviation of the mean. That means within this area here, because this is within 1 of the mean both ways. If I add those two together, I get 68.2%. 34.1 plus 34.1. In my next section, this is going to be a little bit less. This one is 13.6 on both sides. So that's 2 standard deviations out. So for our next blank, within 2 standard deviations is all of these sections added together. So 13.6 plus 34.1, all added together, that should give us 95.4%. So almost everyone is falling within this category here. And then our next one, this is going to be 2.2%. So we can see it's really decreasing as we get away from the mean. And for that one, we are within 3 standard deviations. So that means everybody that's inside here. So we add all of these together, and you should get 99.8%. So that is nearly everybody. And outside of 3 standard deviations, so with the height example, these are people who are very short or very tall. This is only going to be 0.1%. So all of these add up to 100%. Now let's look at an application. So the weights of 50 football players are normally distributed, so they follow that bell curve, with a mean of 178 and a standard deviation of 8 pounds. Okay. So immediately we know the mean, that was the one here, goes right in the middle. So we're going to put 178 here to map it out. So this is where you see most of the players around, because that's the average. Now some people will fall a little bit away from that. So they said the standard deviation is 8 pounds. So this is the mean. And then as we move to the right, we're going to add 1 standard deviation. So add 8, 186. Then we do it again. So this is 2 standard deviations. Add 8, we get 194. And 3 standard deviations. which would be plus 8, 202. And then the other way, the same thing, but now we are minusing or subtracting. So this would be 170. So take away 8 because that was our standard deviation. 162, that's 2 standard deviations. And then a third one would be 154 pounds. And inside of here, these numbers are always the same. Okay? So same percentages always. They never ever change. So 34.1, 13.6, 2.2, and then our last one was 0.1. So now that we've got it set up, we can answer some questions about it. What percent of the players weigh between 178 and 194? So I'm going to highlight this for our notes. So between 178 and 194. So I'm going to look and I see 178 is here. And I want anyone that fits in between here up until 194. So that should be this whole section here. That means 34.1% plus 13.6. Which makes 47.7%. So a little less than half of the players are right in this range here. Our next one says at most 170. So at most means 170 or less. So I'm going to go over to here. Here's 170. And at most is going to tell me that I should be anything below 170. So that means I'm adding all three of these together. So 13.6, 2.2, and 0.1. When I add those all together from here, that gives me 15.9%, because it said what's the probability, which can be given as a percentage. C, what is the probability that a player weighs less than 162, or, which tells me to add, greater than 194. So less than 162 is right here. So anything less than that is just those two little 0.1 and 2.2. And we're going to add that to the greater than 194. So 194 is here. So the same section size is 2.2 and 0.1. Now when you add all these together, that's 2.3 and 2.3, which adds up to 4.6%, because it said, what's the probability? So we can give it as a percentage. The next question says, how many players? Now I see that it says how many. So now I need a percent, but I want to know at the end how many it was. Between 170 and 186. Well, that's from here up to here. 34.1 plus 34.1. Which makes 68.2%. But it said how many. The total people was out of 50. So I'm going to figure out what's 68.2% of 50. So in my calculator, I'll type that as 0.682 times 50. Just divide by 100 or move the decimal place twice, which gives me 34.1. Since it said how many players, though, I can just round this to 34 players.